First up, what do we start with?
Given.
Good. Okay. So 4.32 mole. We have to convert this, right? So it's going to be MgCO2. All right, magnesium is Mg plus 2, and then carbonate is CO3, so carbonate is CO2 minus 2. Okay, so that gives us this. What's the next thing we do? What goes in the bottom? One mole. Good. It's got to be mole, right, so that they cancel out. And what's going to go on the top? Yeah, grams are going to go on top, if possible. Okay? Now, can you go from moles to grams? Yes. Yeah, we learned how to do that, right, with the mole flow chart. To go from moles to grams, what do we have to use? What's the thing called? It's 1 mole equals what? Molecular mass, right? Molecular mass. Good. Where do we get the molecular mass from? Periodic table. Yes, we have to do a lot of work before we can figure out the numbers. But the units are going to be grams of MgCO2, all right? And it's going to be 1 mole, and then we have to figure out that part. So, MgCO2, I'm going to need your help with this. What's magnesium's molecular mass? 24 point what? 31?
Yeah.
Okay. Carbon we know is 12.01 and oxygen is 16.00 times 2 gives us 32 plus 12.01 plus 24.31. All right, what'd you guys get? 68.32. Okay. Is everybody cool with that? Yeah? Okay, great. So when you multiplied 4.32 times 68.32, what did you get?
295.
295?
Yeah.
Okay, 295. Sig figs, 3, right? So that's cool. Mole cancels out. So this is grams. MgCO2. Is everybody cool with that? Yeah? Okay, the next problem. The next problem, it's the same thing, but it says find how many formula units are in the above sample. Why did it use the word formula units in this? Jacob?
Because it's an ionic compound.
Good, it's an ionic compound, so we have to use the nomenclature, the words formula units for it. Now, it says how many formula units are in the above sample. You can start with what we just discovered, what we just converted this into, which was 295 grams, because 295 grams equals 4.32 moles of this stuff, right? Okay, but let's check this out. Let's look at the mole flow chart. The mole was in the middle. Grams was over here. And then over here, we have formula units. And then as well as molecules, because they're the same. It's just if it's ionic or if it's covalent, right? So would we start with the 295 grams or would we start with the moles? Probably start with the moles, right? For 2 reasons. One, if you messed up the first problem, you're going to mess up this problem because you're going to have the wrong number. Also, you're going to start with moles because it's the shortest route to go from moles to formula units, right? How do you go from moles to formula units? 1 mole equals what? Good, 6.02 times 10 to the 23rd formula units. Okay, so what am I going to start with? Yep, 4.32 moles of magnesium carbonate. All right, what goes on the bottom? Mole. 1 mole again, yep. What goes on the top? Yep, 6.02 times 10 to the 23rd formula units. 2. All right, and then what do? Okay, so once you put it in your calculator, well, to put it in your calculator, it's going to be 4.32 times 6.02, that E button, 23, right? That's going to give you 2.60064 times 10 to the 24th. Okay, now with this we need to talk sig figs, right? What are we going to round it to? How many sig figs? 3, right? We're going to round it to 3 sig figs because what's given is 3 sig figs. So it's going to be 2, 6, and then potentially that 0, because there's another 0 after it, we leave it. So it'll be 2.60 times 10 to the 24th formula units. Of magnesium, carbonate, and I'm out of space. Okay. Any questions with that one? No? Okay. Now the next one is what? How many atoms are in the sample or something? Okay. Yeah. So what would you start off with for the next one?
The number of formula units.
Good, the number of formula units. Yeah, you could do that. You could start with the number of formula units because formula units you could then convert into, I know it goes down, but I'll make it go up. That'll go to atoms. Would you be wrong if you started with moles?
No.
No, because that's what's given, right? Mm-hmm. So you could do that and do 2 steps. Would you be wrong if you started with grams?
No.
No.
Unless.
As long as you did the first part right,
Yeah.
you'd be right on this too, right? So that the problem with that would be though, you'd have to go 1, 2, 3, right? So there'd be a lot of converting there. And if you do it these different ways, that's fine. Your answer may be slightly different just because of rounding though, okay? So there's nothing wrong with that as long as you stick to the right number of sig figs. But just realize if you do something different, you may get a slightly different answer. And by slightly, it would be like maybe 2.61 or 2.59, like something pretty close. But again, rounding makes a difference, okay? So you can do however you want. So we're going to start with formula units. So we'll have 2.60 times 10 to the, 24th? Formula units of MgCO2. All right. Now, what goes on the bottom here? Formula units, good. What's going to go on the top? Okay. Let's talk numbers. What number is going to go on the bottom? About 1. 1, good. Yeah, there's 1 formula unit in how many atoms? Or how many atoms are in 1 formula unit? Yeah, what is it in this one? How many oxygens?
2.
How many carbons?
1.
How many magnesiums?
1.
Yeah, it's going to be 4.
But it's only for oxygen. How many atoms?
Oh, it only says for oxygen?
Yeah.
Oh, man. What about that? Should have read. Yeah, got to edit that out. Man. All right, no problem. So this is why it's important to read the problem. Now I don't have to edit it out. All right, so instead of 4, we're going to have 2 atoms of oxygen. Good. And let's multiply. Oh, I guess we didn't need a calculator for that. 5.20 times 10 to the 24th atoms of oxygen. All right. Any questions?